So first we have discussed about the significance of this transformation, okay, so that it can help us to understand the concept of gauge transformations. And since these formulation of these gauge transformations are made in electrodynamics, therefore it is also necessary for us to know about electrodynamics. Actually we all know about electrodynamics, but for assistance let us briefly recall here about the basic structure of electrodynamics. Okay, so what is electrodynamics? It is basically the story of electric field and magnetic field. And if we talk about static fields, that means constant fields, then we can separate out into two parts. One is the electrostatic, that involves the electric field only, and other one is the magnetostatic, that involves the study of magnetic field only. Okay, then we know that the source of electric field is the electric charge, while the source of magnetic field is the electric current. So this is basic things about electrostatic and magnetostatic. That means the study of electric field and magnetic field. Okay, and after that we have Faraday's law of electromagnetic induction. So what is electromagnetic induction? It says that if the magnetic flux changes through a coil, then there produced a induced EMF. Okay, or in other words, an induced electric field is produced corresponding to the induced EMF. That means a magnetic flux, changing magnetic flux produces a electric field. Okay, in conclusion we have that a changing electric field is always associated with a changing magnetic field, and conversely a changing magnetic field is associated with a changing electric field. That means electric field and magnetic field are actually interconnected. We have to study them on the same ground, that means under a same theory. That means the electric field and magnetic field are actually two different manifestation of the same electromagnetic phenomena. Okay, so we have to study the electric field and magnetic field under a same theory, and that is nothing but the electrodynamics. Okay, then we know that a complete theory of electrodynamics was developed by Maxwell, and it is commonly known as Maxwell's theory of electrodynamics. Then Maxwell theory of electrodynamics basically composed of four well-known equations which are known as Maxwell equations, and these equations are that divergence of E is equal to rho by epsilon naught, divergence of B is equal to 0, curl of E is equal to del B del T, then curl of B is equal to mu J plus mu epsilon del E del T. Okay, so by Maxwell's theory we basically mean about these four important equations. Okay, Now this present study, that means gauge transformations in electrodynamics, we basically require these 4 equations. So our basic focus will be on these 4 equations. Okay, so we will start the main part of this topic with these 4 Maxwell's equations.